All right. Um, so your review for your assessment coming at you on Thursday this week. So there's kind of three big ideas. So the normal curve with the empirical rule, number one and number two cover that. And then we did some work finding the mean and standard deviation. And then we did some work using z-scores and the percentile table. So you'll need this table to complete this review, and you'll also need it for your test. All right, so number one, draw a normal curve, label the mean, 3 standard deviations on either side of the mean, and label the percentages for the empirical rule. So, all right, so we have our mean is in the middle, and then a normal curve looks something like that. 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. So we go 3 standard deviations in each direction. So this is 1, 2, and 3. This is -1, -2, and -3. All right, standard deviations. And then for the percentages, well, within 1 standard deviation of the mean, we will find 68% of the data. Within 2 standard deviations of the mean, so including what's in the middle, we find 95% of the data. And then finally, within 3 standard deviations of the mean, so -3 to +3 standard deviations, we find 99.7% of the data. So there's data outside that, but very, very little, because any set of data will have 100% in it, right? All right, so that's called the empirical rule. You can break down each section and figure out percentages for each one, but it's better to just remember that and then figure it out as you're working on other problems. All right, so sometimes we call the empirical rule the 68, 95, 99.7 rule, and that is just to correspond to those percentages. All right, so we'll use the empirical rule here in number 2. A sample of second grade students' heights were taken at a local elementary school. The results were normally distributed with an average height of 46 inches and a standard deviation of 3. So average height, that's our mean, is 46, and the standard deviation is 3. What's the probability that a randomly chosen student is all of these uh, categories? So the first thing we should do is draw a normal curve and label it. So here's our mean, it's 46. And then if we go 3 standard deviations in each direction, we can use the standard deviation of 3 to label those. So 46 plus 3, 49 plus 3, 52, and plus 3, 55. 46 minus 3, 43, minus 3 is 40, minus 3 is 37. Okay, so shorter than 46 inches. Well, the mean is 46 inches, and so half the data would be on each side of it, so that's 50%. Okay, taller than 40 inches. Okay, so there's all sorts of ways to figure out each section. So taller than 40 inches is going to be, oh, we have some typos here. Okay, so I'm going to get to these in just a second. Taller than 40 inches. So here's 40. We want to know this area, all of this. Okay, so this part of it would be 50%. And then this part, if we look back here from -2 to +2 is 95%. So right in the middle would be half, like this part would be half of 95%, and this part would be the other half of 95%. So with the part that we're looking for right here, that's going to be half of 95%. So 95 divided by 2. All right, so we have a total of, so 50 plus 95 divided by 2 is 97.5. So 97.5% would be taller than 40 inches. 97.5%. Okay, shorter than 48 inches. So I will have already changed this on your paper to 49 because this problem is intentionally using the empirical rule. And another problem, it can be anything because you're going to be using z-scores. All right, so shorter than 49. And then actually for part D, that 54 should be a 55. Again, I will have already changed this on your paper because I just got here this morning. I haven't even copied these for you. The rest I think are good. Okay. So for C, shorter than 49 inches, I'm going to draw a new curve just because it's easier. Like this is 46. This is 49. It's plus 1. So I know this much is 50%, right? And I'm looking for shorter, so all this area. I know that much is 50%. This part right here is half of our first section, half of 68, because it's plus 1 standard deviation only from the mean. And so right in the middle of this will be half on each side. So I can assume this piece right here is 68 divided by 2. Okay, so we're adding together 50 plus 68 divided by 2, and we get 84. So C is 84%. D, between 43 and 55, I'm going to draw a new curve. It just is easier if I look at a new one each time to figure out where everything is. So this is 46, the mean. 43 is 1 standard deviation below. So right here, 43. And then 55 is 1, 2, 3 standard deviations above. 1, 2, 3. So I'm looking for this space here from 43 to 55. So this 43, it's the same size as this was right here. 68 divided by 2 is 34. And then the other side of the mean, up to 55. So 55 is at plus 3 standard deviations. And I know that within 3 standard deviations is 99.7%. So from the mean to that plus 3 standard deviations is half of this. Okay, because this is right in the middle. And so you can assume it's equal on each side of that. So half of 99.7 or 99.7 divided by 2. Okay, so I'm going to use 34 for the left side of the mean, and then plus 99.7 divided by 2 for the right side. 83.85. 83.85% for D. And then finally, 40, shorter than 43 inches or taller than 49 inches. Okay, so what's that going to look like? Here's our mean, 46. So 43 is one standard deviation below the mean. 49 is 1 standard deviation above. So shorter than 43 or taller than 49. So what's not part of the answer is this piece in the middle. And since this is -1 to +1 standard deviation, this middle piece is 68%. So I'm going to find this, what's on the outside, by 100 minus 68. And 100 minus 68 is 32. So for E, it's 32%. All right, page 2. So we have some data here. We're going to find the mean, standard deviation, and then we're going to plot the points and then talk about normal distribution. All right. So students' random selection of students at Everett High were asked how many pets they've owned in their lifetime, and the results are shown here. Calculate the mean and standard deviation of this data. Create a scatter or a dot plot. Mark the mean on the plot, and then we'll decide whether or not it could be modeled with a normal distribution. All right. So here we go. Whenever you're going to do this, I recommend clearing the memory. So second plus 7, 1, 2. And all right, so to input the data, we first go to stat right here, and then enter, and then add in the numbers. So 0, enter 4, enter 3, enter 2, enter 6, and 3, 5, 3, 4, 2, 1, 3, 5, 3, 4, 2, 1. All right, and we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So yes, I've got them all in here. Okay, so once your data is in, your calculator will find the mean. You hit stat again, arrow over to calc, and then enter, 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 enter. So our mean is 3. Standard deviation, right here, 1.65. I'm going to round that to 1.7. Okay. All right. So Mark, now we're going to do the data plot, and oopsie, this should go down to 0. Okay. So I love using like a marker for a dot plot because it makes like the right size of dot. So 0, 4, 3, 2, 0, 4, 3, and 2. And then 6, 3, 5, 3, 6, 3, 5, 3. And then 4, 2, 1. 4, 2, and 1. Okay. Wow, look at that. So this mean is right here. Here's the mean, because the mean is 3. And this is just like perfect distribution, right? It goes 3 in the middle, 2 on each side, and then 1 and 1. And so I would say this could be modeled with normal distribution just because it's totally symmetric. It has one mode. So it's unimodal, meaning it has like one big peak. And then if we think about one standard deviation would be 1.7. So 1.7 above 3 is 4.7. So this would be like plus 1 standard deviation would be here. And then taking it away, let's see here, 4 minus 1.7 is 1.3. So this would be minus 1 standard deviation. And it looks like normal distribution would be a good model for this. Okay, on number 4, we have the same idea, and then we'll make a dot plot. So when you need to make a new list, stat, enter, and then you just arrow up to L1, push clear, followed by enter, and then it clears the list. All right. If you don't remember that, you can always just clear the memory, and then it takes everything out of the list anyways. So we have 1, 2, 0, 3, 2, 2, 0, 3, 2, 2, 4, 0, 0, 1, 1, 4, 0, 0, 1, 1, and then 8, 3, 0, 0, 8, 3, 0, 0. Okay, and looks like we should have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we're good. Got them all in there. So now I'm going to find the mean again. So stat, arrow to the right. So it says calc, enter, 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 enter. Our mean is 1.8. Right here, standard deviation 2.1. 1.8, 2.1. All right, here we go for the dot plot. Okay, so 1, 2, 0, 3, 2, 2. 1, 2, oh, not 0. Okay, so 1, 2, 0, 3, 2, 2. 4, 0, 0, 1, 1. 4, 0, 0, 1, 1. 8, 3, 0, 0. 8, 3, 0, 0. Okay, so another characteristic of normally distributed data is that the mean and the median, so the number in the middle of the data, and the peak, they're all the same value. So 1.8 is here. And so if our mean is right here, you can tell like it's not symmetric. It's so different than this one. Here we have the mean and the median are the same. It's symmetric. It's unimodal. All of those things. But down here you can tell like it's definitely not. This is not something that we could say is normal distribution, normally distributed. All right. Last page. So now we're going to be working with z-scores. And so you and your friend are analyzing how well designed Mr. Chalman's latest geometry test was. The results are normally distributed with an average score of 76. So our mean is 76. And standard deviation of 4. So standard deviation is equal to 4. Find the z-score of a student who scored 93. So our z-score formula, we take the data point, the 93. It's above the mean, so I'm expecting my answer to be positive. Take away the mean, and then divide by the standard deviation. So the dividing part comes last. So you can either put 93 minus 76 in parentheses before you divide by 4, or just find the answer and then divide the answer by 4. So we get 4.25. So that means this student's score is 4.25 standard deviations above the mean. The next student scored a 70. 70 is less than 76, so I'm going to expect a negative z-score. 70 minus 76 divided by 4. 70 minus 76 is negative 6, and so then that divided by 4 is negative 1.5. So 1.5 standard deviations below the mean is what that means. What's the probability that a student scored below 60? So now we want to know, okay, if our mean is 76, and then 60 is down here somewhere, what's the probability somebody scored in that area? So what we have to do first is find the z-score, and then take the z-score and find the percentage on the table, on the percentile table. Okay, so let's see here, 60 minus 76 divided by 4. Okay, 60 minus 76 is negative 16. That divided by 4 is negative 4. Oh, darn it. Okay, So unfortunately, these can't be answered on our table because our table only goes to negative 3.4 standard deviation. Shoot, so I'm gonna change this and make this a 66. So once again, I'm going to change this one to 66 as well. Okay, so I'm going to fix some of these so that we can use the tools that we have and it makes more sense. Okay, so let's pretend that this said 66. It'll be 66 on your paper when you get it. So I just had someone email me. Someone made this and emailed it to me this morning. And I thought, well, I'll just make the answer key video and then go copy it. So I'm glad I'm doing this now before copying so I can fix all of these things before you actually work on it. Okay, so 66 minus 76 is negative 10. Divide that by 4 and you get negative 2.5. Okay, so negative 2.5 is on our table. It's right here. And negative 2.5, so then we would go to the 0 column because it's just negative 2.5. 0.0062. So we get 0.0062, which is 6.2%. Okay, next is between a 66 and 70. So we already just figured out this part. I know this part. So then if we find the 70, then we're going to subtract to figure out what's between them. Okay, so we have 6.2% for the 66. Now we're going to find it for 70. So 70 minus 76 divided by 4, that's negative 6 divided by 4, which is negative 1.5. Okay, so on our table here, negative 1.5 is, oops, I made a mistake. I'll fix it. Negative 1.5 is right here, 0.0668, which is 6.68%. And I made a mistake here. Sorry. This decimal is in the wrong place. That's 0.62. Less than 1%. 0.62%. Makes way more sense, actually. So then in between there, to find that shaded area, this part right here, we're going to take this 6.68, subtract the 0.62, and I am just going to use my calculator to make sure I don't make a mistake again. I get kind of flustered when there's typos and then I start making all sorts of mistakes. 6.68 minus 0.62 is 6.06. So 6.06% is between 66 and 70%. Okay, so what's the probability a student got an A, which is 93 or higher? This is happening again. I'm just going to go ahead and find the z-score and use this as is. It's not going to be on our table, but it's okay. So, got a 93% or better. All right, so what we're looking for, again, up here is 93. We're looking for this part here, okay? And so the z-score, 93 minus the mean divided by the standard deviation. So 93 minus 76 is 17 divided by 4 is 4.25. And so 4.25 is not on our table. It only goes up to 3.4, and 3.49 has 99.98% of the data is less than 3.4 standard deviations above the mean. So think about 4.9 standard deviations above the mean. The chance is like almost zero because this is almost 100% and it's not even at 4.25 yet. Okay, so I would just say almost zero. Now, when you take your test, all of the data you're going to be working with, you will be able to find on your table. Okay, so all of it will be on the table. So finally, your friend says 25% of students scored above 86. Is your friend correct? Well, let's see. What is the z-score of 86? So your friend is claiming that, oops, that's a little skewed, but just pretend it's not. With a mean of 76, that 86%, or sorry, 25% scored above 86. So this area right here. So we're going to find the z-score for 86. So 86 minus 76 divided by 4 is 10. Divided by 4 is 2.5. Okay, so a z-score of 2.5 even is 99.38. So what that means is 99.38% of the data is in this area. So above 86 would be 100 minus 99.38, which is like less than 1%. 100 minus 99.38 is 0.62. So your friend is not correct. Okay, that is the end of your review.